Hey everyone! Welcome to Data Engineering Unlocked, the channel where we break down complex data engineering concepts into simple, easy to understand lessons. Whether you're a beginner or someone looking to advance your career in data, you're in the right place. In today's video, we'll answer a fundamental question. What is data engineering? We'll explore why it's important, what data engineers actually do, and how you can get started in this field. By the end of this video, you'll have a clear understanding of the role of data engineering in modern businesses and why it's one of the hottest tech careers right now. So, if you're excited to dive into the world of data, don't forget to hit that like button and subscribe for more data engineering content. What is data engineering? Data engineering is the backbone of modern data-driven decision-making. It involves designing, building, and maintaining the systems that allow companies to collect, process, and analyze data efficiently. Without data engineers, businesses would struggle to handle the massive amounts of data generated every second. Think of data engineering as the plumbing system of a house. Just like pipes move water from the source to different parts of the house, data pipelines move data from various sources, like databases, APIs, and logs, to a centralized location where it can be cleaned, structured, and analyzed. For example, let's take an e-commerce company. Every time a customer browses a product, adds an item to their cart, or makes a purchase, data is generated. This data is scattered across multiple systems: inventory, payments, shipping, and customer support. Data engineers build the infrastructure that brings all this data together so that analysts and data scientists can make sense of it. Without data engineers, raw data would be messy, incomplete, and unreliable, making it difficult for companies to make informed decisions. Why is data engineering important? In today's world, businesses generate an overwhelming amount of data. Think about social media platforms, streaming services, financial transactions, and IoT devices. Without proper data engineering, this data would be useless. Let's take an example from Netflix. Every time you watch a movie or series, Netflix collects data on what you watched, how long you watched, and even if you stopped midway. But how does Netflix use this data to recommend the next show? That's where data engineering comes in. Data engineers build and maintain the pipelines that move this data to the right places, ensuring it's processed correctly. Once the data is structured and stored properly, data scientists and machine learning models can use it to create accurate recommendations. Another example is financial institutions. Banks process millions of transactions daily. If there is fraudulent activity, they need to detect it in real time. Data engineers ensure that transactions are captured, processed, and analyzed quickly so fraud detection systems can react instantly. In short, data engineering enables businesses to turn raw data into actionable insights, improving customer experience, optimizing operations, and driving innovation. What do data engineers do? So, what exactly does a data engineer do on a daily basis? Their primary responsibility is to build and maintain data pipelines, automating the flow of data from various sources to centralized storage systems like data warehouses or data lakes. They work with ETL, extract, transform, load processes to ensure data is extracted from different sources, transformed into a clean, usable format, and loaded into a database or warehouse. Data engineers also manage data warehousing solutions, such as Snowflake, Amazon Redshift, and Google BigQuery, to store and organize large amounts of structured data. When dealing with big data, they use technologies like Apache Spark, Hadoop, and Kafka to efficiently process massive data sets. Another critical responsibility is optimizing data performance, ensuring that systems run smoothly even with high volumes of data. Lastly, they focus on data quality by implementing validation and consistency checks, ensuring that businesses work with reliable and accurate data. Key technologies in data engineering. To become a data engineer, you need to master several key technologies. The most important programming languages are Python and SQL. Python is widely used for automation, data transformation, and working with big data frameworks, while SQL is essential for querying and managing databases. Data engineers also work with various databases and storage solutions, including relational databases like PostgreSQL and MySQL, as well as NoSQL databases like MongoDB and Cassandra. Cloud storage solutions such as AWS S3 and Google Cloud Storage play a vital role in modern data infrastructure. They also use ETL tools like Apache Airflow, Talend, and dbt, Data Build tool, to automate data movement and transformation. When working with big data, they rely on frameworks such as Apache Spark, Hadoop, and Kafka. Additionally, understanding cloud platforms like AWS, Google Cloud, and Azure is crucial, as many companies are transitioning their data infrastructure to the cloud. Services like AWS Glue, Google BigQuery, and Azure Data Factory are widely used for data processing and analytics. How to get started in data engineering. If you're interested in becoming a data engineer, here's a step-by-step guide to get started. First, you need to learn SQL, as it is the backbone of data engineering. Mastering SQL will allow you to query databases efficiently and perform complex joins and aggregations. Next, focus on Python, which is widely used for automation, data manipulation, and working with big data frameworks. Once you have a solid foundation, start learning about ETL processes and data pipelines to understand how data moves and transforms across systems. Then, get hands-on experience with cloud platforms like AWS, Google Cloud, or Azure, since most modern data infrastructure is cloud-based. Learning big data technologies like Apache Spark, Kafka, and Hadoop will also be beneficial when working with large-scale data. To stand out, build real-world projects such as setting up a data warehouse, automating an ETL pipeline, or processing real-time streaming data. Finally, consider obtaining certifications like AWS Certified Data Analytics, Google Cloud Professional Data Engineer, or Microsoft Azure Data Engineer, which can boost your credibility and job prospects. That's it for today's video. I hope this introduction to data engineering gave you a clear understanding of the field and its importance. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss future videos. Leave a comment below if you have any questions or if there's a specific topic you'd like me to cover next. See you in the next video, and keep unlocking the power of data.